Thanks for having me. Thanks for coming. It's always a treat for me to talk to people who care about, try to promote and endorse open science practices. So the last 7 years, I've been based in Hong Kong, at the University of Hong Kong, and before that, I did my PhD in Hong Kong in a different university at HKUST, University of Science and Technology. So I've spent quite some time in Hong Kong trying to build a community that cares about open science and tries to promote practices regarding open science and all the different links and all the different domains that open science touches that also influence from libraries, open access, and just being able to read and disseminate research information to just how to do research well, how to improve our research practices. So it's very nice to see that people are paying attention to this, that you have workshops on this, and just going over the Chinese University of Hong Kong regarding their website on data management. It's nice to see that this is growing and more people are taking this up. So really thank you for coming and attending. I hope that I'll be able to make this valuable for you. In the spirit of open science, everything that I do, including my talks and all the slides and all my teaching materials, everything is available for you to download. So you can either scan this QR code or you can go on this link here in the mgto.org 2025 CUHK, and this link will always appear over here on the bottom right. So if at any point you have any questions regarding anything that's happening in this session, you're welcome to write this in the chat, and I'll try and keep track of this. All right, so I'll just say that many of these slides are not my own. They're based on recent presentations by the Center of Open Science and many of their OSF tutorials. I have a lot of materials on the Open Science Framework, but something happened in the last month that required me to change everything that I do or plan for this workshop, and that is the Center of Open Science had a refresh of what it is that they're doing. So the entire website looks very different. It's more of a modern style. So I've tried to adjust some of the slides. I took some of them. I went quickly and tried to take some screenshots. So we'll walk through these things together. Most of the things seem like nice, but it's still like a work in progress. So some things might be a little bit slower. Some things might be different than the functionality that maybe if you're familiar with the Open Science Framework that you've seen before. Another thing is that hopefully this presentation will be shared together with the other presentations that I gave on open science. So if something that you've seen here that we're talking about is interesting for you, you can go and check out the other ones on YouTube. And if you want to know how to share this with your students and how to teach others in your lab, then everything, all the slides is available in all my courses with the videos and the recordings is on the Open Science Framework. So you can see that I also use Open Science Framework for my teaching, and I'll show you what that looks like, and then on YouTube as well. So one of the first questions that I am being asked constantly is like, why would we even care about open science? Now I think it's a little bit more taken for granted, but I think it still needs to be said because some are very slow to adapt to this. Up until 2022, I really had to go around and try to convince people what is the value for them and what is the value for the community and try to speak about this. But now this is definitely a growing trend, and more places around the world are adopting this. And in 2022, UNESCO came up with this declaration that are saying that people should endorse open science. So it's nice to see the world coming together and saying that they have a recommendation for open science. So it's not just a group of open science movement scholars, but it's becoming a world movement towards a certain direction. In addition, places like the US have NASA or big organizations are adopting this. So 2023, following 2022 in the UN, was 2023 the year of the open science. And you can see the Center of Open Science working with the Biden administration, the NASA, in order to promote open science. So that gave a big push to the entire community, and lots of events and things came up. But even since then, in 2023, when the G7 leaders come together and they discuss open science, it's very surprising to me to see in science and technology saying that the G7 will promote open science by using FAIR principles and all of that. So it just seems like this is definitely a direction that's happening worldwide, taking very strong promotion in the European Union and North America. So many things happening. It's good to keep track of these things, and now it's no longer just like on the outskirts of science, but now it's becoming a lot more mainstream. So a lot of people have different meaning for what open science says. They take it into different directions, but this is kind of like a nice diagram that summarizes everything together. The most important domains that I think, there's other things that we should perhaps be talking about, but mostly it's talking about open methods. So everything in the research process, from having an idea to writing down the research question and the research hypotheses, and then starting to think about, so what are the methods, how should we do certain things, trying to in advance think about, okay, so if we run these kinds of methods and we get this kind of data, what are we going to do with this data? So what kind of an analysis fit the hypotheses in order to answer the research question? So we start from like open methods and just opening up as much as possible and how to share this transparently, and also maintaining some privacy so that you can control your information, or you can protect your participants. Then it comes to open data, and open data is actually could be any form of data. So research data, and then educational data that you have over here, educational resources. So from the methods to the data and the educational resources, making things as open as possible. But open data by itself could be very difficult to understand. So having some identifiers and having some kind of information about the data in order to help others analyze this. But then going beyond that to also having open source. So whatever code comes with the data also needs to be shared together, so they complement one another, in order so that when we have open data, that we know what kind of code ran on this in order to match the methods that were shared in open methods. Open access is a big theme. I'm sure the library at CUHK is thinking about this constantly, because these are rising costs for the Hong Kong taxpayer and worldwide. The European Union is trying to tackle this with all kinds of programs, but generally shifting the publication model so that people can publish for free, and the taxpayers and our audiences, the stakeholders, can access that information for free, so that research really lives up to the scientific ideal of everybody can access this information and use it for the betterment of mankind and globally. And then finally, there's all kinds of things about how do we ensure credibility? How do we know that something is solid? So typically the way that we've worked in academia is that we submit this to peer review, but then it's hard to tell what peer review is, because this is a closed model. We don't see who did what kind of review, and then we only see the outcome. So there's a whole movement and a whole direction trying to improve peer review overall, and then making it more open and more credible, so that anybody can evaluate this and understand what happened in this process to ensure that this is really high credible, rigorous research. Right. So today we'll be focusing mostly on this component, open data, although I'll touch on how to do some of the other things, like open source, like open educational resources, and so forth. So many universities are tackling this situation, like how to manage the workflow, how to manage the life cycle of a research project, from the beginning, searching and discovering, developing an idea and designing a study, all the way out to the publication of a report, and making sure that even once there's an academic article and it's out there, people are using this, that people can build on this, people can revisit this, people can evaluate this and assess this in order to make sure that this is solid. And the one platform I think that takes care of all of this and is a real revolution is this Open Science Framework, OSF, that really has so many components. It's difficult to cover everything that they do, but helps you with this entire life cycle. So they have all kinds of different capabilities. They allow you to plan, collect, analyze, and share. We'll touch on all of this. There's lots of research transparency. So there's versioning every change that you make, every step that you take, every change that you perform on your project. Everything is documented and can be communicated to everybody. Sharing as much as possible, but you can also set permissions, so you can allow people to either view or edit or have some kind of access or limited access to some component. So they have all these things about how to manage a collaboration, how to share things with the public. And then they have all kinds of services, and we'll touch briefly on those in order to do preprints. So that means that before this goes into peer review and before this is published, you have a manuscript and you want to share this with the public in order to get some feedback or in order to allow for citations or getting credit for your work and ensuring that this work is always associated with you. So preprints, registrations, it's a growing trend, a pre-registration. We'll talk about what that is. And then the more advanced notion of a pre-registration, that's called a registered report. And then the core functionality of OSF is this OSF project. All right, so I'll try as much as possible to just do things hands-on. Some of this might seem like it's very, very basic to you. So you might think like, why do I even need to show this? But I think it's worthwhile just like showing you how these things look, just so you have a full understanding of what that looks like if you want to share this with other people so that they'll know. So I'm just going to show you my dashboard. So when I log into OSF, this is what I see. So you can see on the top right, you have my name. And then on the left, you have things like home, search the OSF, my OSF, registrations, preprints, all kinds of meetings and institutions. And then over here, you have all of my projects. So as you can see, I'm a very active user on the OSF. OSF is for me daily, if not hourly, use. Like everything that I do is on the OSF. So for example, this one here is a talk that I gave at University of Bucharest. So at the University of Bucharest, when I attended, all the slides were there. And then finally, I uploaded the video. So it has a bunch of websites associated with it. So for example, it has a wiki. This is what a project looks like. A wiki where I posted the YouTube video that is associated with this talk at University of Bucharest. And then there's a bunch of files in the OSF storage, and you can open these files. So for example, this is a presentation. So finally, the presentation that I'm giving right now will also be uploaded. It's like a poster, and you can see that actually there's a parent project. So this is part of a hierarchy. So OSF has a hierarchy of projects that allow you to have one head and then many, many different children. So parent, children, and then you can move from one to another. So all of my talks are under this one project. So what you can see here is that there's a lot of things a lot of functionality that is hidden behind all of this. You can see how much is stored. So actually just this little project has 110 megabytes. What is nice about the Open Science Framework is that it has very generous limits. So I have yet to hit any limit on the Open Science Framework, and I've shared gigabytes, many, many gigabytes of a lot of content. So many other places might limit you to some kind of storage, but for me, at least in psychology, I've never seen that. Perhaps if you're in computer science or you share large data sets, this might be some kind of concern, but I don't, like everything can be overcome and you can get additional on top of that. But I think for everyday use, for the typical researcher, this is has no limit, can take care of everybody. You have your metadata, and what you can see here is that it has the contributors, and I'll show you how to add contributors and how to share this with others. Could have a description, date created, license, so you can set what kind of sharing you want this with others, so CC BY, attributions. It has a project DOI, so everything has a fixed URL that can be cited. So you can already, if you open this in a citation, then you should have a DOI that you can use in your references. And then finally here, it has the kind of citation in APA style. So already out of the box, just by me opening one click, you can see that there's a lot of functionality here. And we'll walk through some of the things that are here on the left. But you can see that there's a very nice navigation bar and you can move from one thing to another. I'll show you my profile just to, in setting up a profile, what that looks like. So when you set up a profile, it has all the functionality that we need for researchers in order for them to share what it is that they're doing. So for example, there's this identifier in ORCID.org, so ORCID, and you can see that mine is here. This is my OSF profile link. So if I want to show others my work on the Open Science Framework, this is the link that I give them. And in addition, you can set up all your social media. So I'm on LinkedIn and I'm on Twitter X and Google Scholar, of course, and ResearchGate and all of that. So if I just hit the edit profile, you'll see that it's very easy for you to update this. So once you sign up and once you log in, then you can just update everything here, including your citation previews. So sometimes with my colleagues and my students with Cantonese Mandarin names, there's like a little bit of a confusion because, the first or the given name has two characters or two different words. So sometimes you just want to show people how to cite your name, what that looks like. Is it the first character of the first syllable, the first Chinese character or not. So that's something that you might want to add here as well. Oh, the social engagement. So you can see there's like lots of platforms over here. Employment for people to keep track of where you are and what you're doing. Then education if you want to. So it could serve a little bit like as your CV. So I think OrgID also does something like this. It just helps link everything together. On the My OSF, once you have a profile, you can start creating projects or registrations or preprints. So if we go to home, you'll see that everything operates here. So I did a little bit of testing for us to show, and then you can, of course, search all of that. Yes, testing. So you can have like a key, and you can see I've done a bunch of testing. So we'll show you the ones that match these criteria. You'll see that I have a lot of projects, but I also have some registrations of other things that I conducted a pre-registration on. So all the things, for example, I did a pre-registration today for this workshop called testing that I'll show you. But all the other projects that have kind of a pre-registration appear here. And in addition, some files that are on OSF can be made into a preprint, an official preprint with its own DOI, so you can make that public. So you can see that there's also a lot of preprints that are shared here with all of my projects. So if we take just one of these projects, just see, before I move on, any questions on this? Anything that you'd like me to go over and explain about setting up a profile? It's pretty straightforward. If I just go on if it's a incognito mode, you'll see that if I go on OSF, you go here, you go on a sign-in page, and then you add your detail. You can sign in with your work ID. You can sign in with your institution if they're part of the OSF affiliate, or you can just do the regular email password. Pretty straightforward, and then it just stays logged in. All right, pretty easy then. All right. Yeah, so I think we walked through this. Discover content. So OSF has a lot of things shared in it. You can see not just your own, but you can see others based on a lot of criteria. So sometimes when I prepare a workshop or when I teach a course or when I do my research, sometimes I come in here in order to see have other people done similar things. So when we do open science, when we share everything, we hope that others will be able to find it. If you have a DOI and if it's publicly shared, it's automatically already aggregated on your Google Scholar. So I think it takes, I don't know, a month or two, and then Google Scholar identifies this, detects this, and then adds this to your profile automatically. But you can also go here and find all kinds of things. I don't know, if you search for like open science, you can see that there's like a bunch of things. You can filter this in all kinds of different ways, and you can sort this to the new one, and then you can, based on the creator, the funder, or the license, if you need something. But here you can already see that there's different types. So you've got like projects, registrations, and the different types also have different components and things that are in there. So a project has slightly different things than the registration. And you can see who is affiliated with this project. And you can look at their profile. Perhaps they've done other interesting things. So when it comes to open science, I just look for registrations, preprint. You can even search specific files. So sometimes I look for a PDF or a PPTX that might serve me. We can take and borrow some slides if it's a CC BY and so forth. So for example, here there's an open science workshop in a PowerPoint. So that might help me develop my own. So this is just a very good opening point for me to come and see what others are doing, and for me to try and think about where do I want to go with this? If it's educational, if it's talks, or if it's research, there's probably other people who have shared something. At the beginning, there weren't much when I was starting to use this 2016, 17, but now it's very, lots of users from all over that are doing interesting things. Yeah, so let me see if there's anything that I want to say here. There's a lot of metadata that you can search. All right, sharing content. So I'll start by just showing you how I share content with teaching. So for example, if we go to my website and go to teaching courses, you can already see that on my website, I try to be as transparent as possible and show everybody what it is that I'm doing. Teaching courses, there's a YouTube channel. Teaching portfolio, I even share my evaluations from the University of Hong Kong, and then some talks that I gave about this. But in addition, there's also a mega link here for all of my course materials in one page. So if we open this, we go here, we'll see that I just, as much as possible, share all the courses. If we start from here, you'll see that actually the files preview is empty. There's actually nothing in this project. And the reason for that is that under this project, there's a child of different components. And what you can do is that you can add component for each one of the courses. So you can set up this mega link for all of the courses together. And then for every semester, you can open a different one. So, for example, here, this component, this is the course that I taught in 2023 about research methods. So I can just open that. There's also some linked projects. So, for example, if I have a component that's not under this hierarchy, if there's some tutorial videos that are someplace else, then I can link to them here. When you add a component, you can give it whatever name you want, and then you can decide which storage location. So Europeans, for example, are very sensitive about having everything stored in the EU. So you can have this, for example, in Germany instead of in the United States. And then if you're in the Asia Pacific and you prefer that, you can choose Australia. And once you do this, you can put a description, add some contributors. If there's a parent, you can just inherit the contributors. And then once you create the component, it will appear here, and then you can just go and look at it. So I'll just show you what it is that I do with these courses. So for example, with this course, I just share everything that I can from the course. So you can see that this wiki already has the syllabus, it has the YouTube playlist and some slides from previous years, and I can edit all of those. And the wiki is very, very easy to edit. So you can see over here that you have this formatting, but there's also like a very nice helper here on the top in order to help you navigate this. So if you want, you can just go and add something new. And once you do this, if you save, it will appear here on the view on the left. So if I save here, it appears here, and it's pretty dynamic, and you can make as many changes as you want or revert something for what happened before. You can compare this to earlier versions. So every change that you make has versioning, of course. So you can compare this to 2 versions ago, and then you can revert it to that version in order to go back to a version that you had before if you've made some changes or something doesn't make sense. In addition, you can have as many wiki pages as you want. So you can add a wiki page over here. I have a bunch of things that I use this for. So you can have a little bit like a small Wikipedia for you in this project and add different components from for the wiki pages. So you can organize this in any way that you want. If we go back to this overview, you'll see that there's a bunch of things already. You can see in the files preview that I share the lectures here. So in the lectures, you can see that every week we've had a different folder, and under this folder, you can see that there's a different PPT that the students can go and look at. I share this on this platform rather than just on Moodle, so that everybody around the world can come in, can join, can take these presentations and use. And if the students for some reason are not logged in through HKU, then they can just go and look at this publicly on their Open Science framework. In addition to this, there's all kinds of components. So for example, I'll record all of my lectures. So I added a component, which is another child under this. On the Files tab, you can just navigate this, and you can also download the entire thing as a zip, or you can just drag and drop new files in order to upload these into this folder. So if we, for example, want to start a new one, then I can just go on Home, create a new project. So for example, I can go here, I can call this new course. I can decide I want this in Germany. I can use a template. So if there's already one project that has the kind of hierarchy, has the kind of components that I want, then I can use that in order to already create automatically some of the components inside my new project. And I create this project, and I can just go to it. And then what I can do is go to Files. I can just tell it to go and upload. And then once it's done, it will show up on inside the file. Then I can create a directory, PDFs, create this, and I can also like drag and drop and move things. So for example, I can move this here into the PDF folder. So everything is just like a very simple storage, just like you're doing this in your own Windows. So it has a lot of things in it. And then where was the thing? Component that I wanted to show you. And then you can have another component in there if you just want to upload the lecture videos. So the components are made for you to have different bulks of information. So you can have one for your lecture videos and you have one for slides. And then the nice thing about these ones is that you can decide who are the contributors. So for example, you can have one set of contributors and sharing for your videos, and then one contributors and sharing for your lecture slides. So if you're more sensitive about your videos than you are about your slides, which is the reason why I did the different components here, then you can define this here. What we can do here is just to show you a little bit about how to set up the metadata. So in the metadata, you can decide what kind of license you want. So you can set all kinds of different licenses, CC BY, for example, here, a description, what date it was created, and then contributors. So here I can search for contributors that I want, and then see who is here. So usually from my list of contributors to a contributor, so that's Prasad. And then if I want to add Prasad, I don't know, Krishna here, then I do next. Or I can also add an unregistered contributor. So I can just add, so let's say I can add just by adding an email, and then it will send them an email and saying, you've been added, you can access this. If you want the full capabilities, you can register for an account, but you don't have to because you can enter through this link. So you can choose what contributors to add. Then you can give them different permissions. Some people have read and write, some people have only read. And then you can decide, are they real contributors? Should they be cited for this? Should they be acknowledged for this? So you can decide whether somebody is a bibliographic contributor or not. So I'll show you a little bit what that looks like when I discuss the research. I'll give you an example for our research project that we've had. You can include the funding and the support, and all this metadata regarding the subject is just for others to more easily find this project. So you can add all kinds of tags like course, evaluation, and so forth. And then at the end, it will just appear here, and it will be easier for other people to search this. In addition, there's a tab over here that we'll get to afterwards called a registration to do a pre-registration. Contributors we've seen already, but you can have a nice list of them over here. There's an additional functionality over here called the view only links. So the projects you've seen already perhaps here on the top can be either private, and they're private by default, or they can be made to be public. So if you want them to be cited and if you want them to be shared, you can very easily just tag this and then, are you sure you want to make this project public? Let's say that it's kept private, but you still want to allow people, like for example, peer reviewers or editors, when you submit this to peer review, to come in and see this project. But you only want people who have the link to be able to sign in and see this. So you can create a view only link. You can create this over here, and you can say anonymous peer review, for example. And then it will anonymize the contributor list. So it will not show your name. It will not show who the contributors are. And then if the files that are kept in there also don't have this kind of information, then this will be completely anonymized. So this way, you can maintain the blind peer review just by sharing a link. So for example, you can create this here, and then you can just copy paste this link in order to this is what it's going to look like. So if I just open an incognito mode and I just use this in overview, you can see in view only mode that it shows that this is a private project, and it doesn't show who the contributors are. This is anonymous contributors. So OSF is already built out of the box as something that's meant for academic peer reviewing, that's meant for sharing, also in an anonymized way, also in a protected way. And it says you're viewing OSF through a view only link. So in the preprint, in some of the manuscripts, or when it's sent to peer review, you will have these kinds of links with view only. And then when it is officially accepted, then you can go and make things public at the end. So you can go back here, and then you can say, okay, now I'm ready to turn this into a public project. You turn this, press continue. You can turn this back again, but then you might lose something. So for example, here, you have the benefit of being able to create a DOI, and this is for free. Usually these things cost a little bit of money, but if you go here on edit, are you sure you want to create a DOI for this project? It's a persistent and will always resolve to this page. This is very, very useful for citations. It costs OSF a little bit for each one of the DOIs, but they do this, and you can create as many DOIs as you want for as many components as you want. So once you know that this is public, once you know that this is accepted for publication, once you know that you want to share this with the world and be cited, then you can create a DOI for this project and put this on your manuscript. Okay, so I think we've seen the contributors. Now we have analytics. So nothing is going to be here because this is a new project. But if we go here, let's say one of the courses that I gave, then you can see perhaps there's a little bit more. I'm not really sure. Visits, yeah. So you can see them past month. So they keep a little bit of analytics for you to be able to see kind of like how things unfold in terms of the unique visits, who is visiting. So if you want to see, I don't know, students are using this or not using this, then you can go on here and check this. In addition, you can add to your project. So let's go back here. Yeah. Add-ons, you can add a lot of links. So if you're a researcher and you're using some kind of cloud folder like Dropbox, or if you're developing and you have a GitHub or a Figshare or a Google Drive, and you want this to be part of the entire environment, the project, then you can very easily do this. You can connect to your GitHub. So for example, here, you can, there's all these permissions or the things that you need to accept this, and once you're ready, then you can link to a very specific project that you have on GitHub. Same thing for Dropbox. You can add, update, anything that you want here. All the link services finally will be here. And then for each of the projects, you can set whether you want certain functionality. So we talked about the view-only links. Do you want to allow people to request access to this if it's still private? Do you want to enable the wiki? You can also disable this. Do you want email notifications? And so forth. Do you want this to be instantly or daily? And so forth. So this is kind of like all the functionality in a project that you can do on the OSF. Let me check if there's something else that I wanted to show you. But if you have any questions, then I'm happy to answer them now. Okay.
Thank you, Professor Feldman. Oh, just a quick question. Sorry.
Yes.
So I probably missed this point. Are you able to add collaborators to the platform? And because you mentioned about the blinded peer review process. So I guess the collaborators will also be able to view the content you posted, right? Yeah.
So we do this here in the metadata. It's under this umbrella. So maybe I'll just show you perhaps one of the projects that I have with collaborators. So you'll be able to see. So for example, yeah, so this is one that I did with a thesis student. So you'll be able to see here. So Gladys over here is listed as a contributor. Even when this was private, she had access to this. The way that I edit this is go on the metadata, or I go on contributors over here. And then I can add a contributor. I can also define who is first and who is last. And then I can decide what the permissions are. If I want to add a contributor, I just add it over here. So all the contributors can have access, at least read access, to everything that's in the project. So even if this is a private project, they will still be able to see everything. I can also give them additional permissions. So I can decide that they can also write into this. Or if I want them to administer this together with me in order to edit the wiki or upload files or whatever it is that I wanted to do, see the analytics and all that, I can set them as administrator. Typically, when I work with students, when I make everything public, then they have read permission so they can see everything. They have some recognition credit as a contributor. And then they're just all listed here, and they're listed as first author, so that when there's a citation, then it will show their name followed by my name. But this is where you manage everything, and you can just set the permissions and whether they're contributed and everything else in this interface. So it shows finally here on the metadata as contributors. Is this clear?
Yeah. Yes. Yeah. Thank you. Thanks.
Okay. And then you can see also here in the citation, she appears first and then followed by me, and then revisiting all of that, you can actually edit this. I can also see that there's a little bit of a thing here. Okay, so this, and now it's looking well in the APA format. Yeah. Any other questions, things that I can show you in terms of the function? I know that I did this very, very quickly, but I think almost everything that you can expect from this platform, sharing everything in the research process, you should be able to see here from the navigation bar. There's this one thing that we haven't touched yet on registrations, and I'll come to this in a second. Okay, so now a research example. I'll show you one of the projects that I did with a different student. So I think this was accepted for publication not too long ago, yeah, in the Royal Society Open Science. You can see that usually the way that I did these things is that on the wiki, I try to keep up with the latest of what's happening in this project. So if it's published, then I add a DOI and I say what is the latest preprint. So if this, let's say, is not open access, then they have a link where they can see this. If I just open this link, the thing that I wanted to show you is it's not only that we have everything on the Open Science Framework, and you see all the files and everything that's been done, including the preprint and the print and the thesis that she did, this is based on. But also here, when you look at the actual publication, you'll see that the way that we use the Open Science Framework is even more integrated in that. So for example, we've got the typical abstract, which is okay. And then finally, at the end, we have this materials, data, and analysis code are available on the Open Science Framework. And then we provide the kind of links. So let's say, for example, this was not an open access publication. Then one of the tricks that we have is that we put everything up on the Open Science Framework, including the preprint, and then we just put in the abstract, which is always visible, even when it's closed access, to materials, data, and code analysis provided on the Open Science Framework. And then people who don't have access to this, if this publisher doesn't have any problems with preprint, then you can just directly go and have a look and find the preprint. So this is typical for us to do in abstract. So there's a very strong link between the way that we publish and the way that we create a research project and the Open Science Framework. And now you have this persistent identifier, the DOI, that will always link to the Open Science Framework and everything that we've done in this project. What's another thing that you can see, and I'll talk a little bit about that later, is just how transparent everything is. When you have a platform like this, you can really share as much as possible. So you can see something here called a PCIRR stage 1, a PCIRR stage 2, and these are actually our peer review. So you can see over here that it says stage 2 endorsed for publication by peer community in registered report. So all of my thesis students in the last 3 years have submitted their thesis in the planning stage to this platform called Peer Community in Register Report. And this is a community that gives peer review on preprints. So first we have a plan, a preprint before data collection. We write up as much as possible in order to tell the reviewers, tell editors, this is what we're planning to do. This is called a stage 1. So if we go into the stage 1, you'll see at the beginning we had a snapshot, and then we had the first submission, and then we got some peer review from the community about how to improve before data collection. And then we submit again. And when we submit again, you can see that actually we provide everything. We even do a comparison of what changed between this version and the previous version, and we address all the things that needed to, all the peer reviews. So everything is shared over here, including the reply to the peer reviewers. In addition, we share the power analysis, and we share the Qualtrics survey, and we share the simulated data and the planned code. So you can see all this over here. If we want to download this to be able to do this a little bit better, then we can always go over here and we can download the directory as a zip, or we can the whole project together. So you can see that even over here we have so she did this in Jamovi, so you can see the OMV file, the output from that, and also the data set, the simulated data set, all this before data collection. So the nice thing about this, and the nice thing about peer community in registered reports, which is part of a larger collaboration, is that you can use the OSF, the storage, in order to set the different stages for the peer review and be as transparent as possible about every stage and everything that you've done. And then finally, when you've got our preprint, then you can share that preprint here, not just with a PDF, but also with a Word document for other people to be able to always access this. And because Royal Society Open Science is also completely open access, then can also find the print over here. Let me see if there's anything else. Yes, there's the difference between this and the other one that I showed you. So educational data and just sharing talks doesn't require a registration. But if we go down here, we'll see that there's a linked projects. And in this linked projects, you'll see that me and my student have these two components over here. And these are actually registrations. The interesting thing about these registrations is that one of them was done for us on a stage one. So stage one is that we submitted to peer review our pre-registration. We received all kinds of peer review from the community. And once we and the community, we and the editor and the reviewers agreed that this is the best plan, then that community, peer community in registry report, automatically created a pre-registration for us. So we actually did not do this linked project. They did this for us. But in addition to that, we went on the registrations and we created the registration. I'll show you what that looks like. So this is what a registration looks like. So you have data, analytic, materials, papers, supplements, and all of that. You can see that there's a registration here saying this is a stage one, in principle acceptance, received. See all the materials in the subfolder in the files. And this is frozen. You cannot change this. There's no way of anybody to alter this. This is from now until eternity, this is what it's going to look like. So if you go here to the files, you'll see that it says archive of OSF storage. So this is not just a regular storage. This is already frozen in time, and I cannot upload to this or change this in any way. This is the pre-registration of everything that we've done with the community. So there's a pre-registration of the Qualtrics, of the simulated data. So everybody knows that before I did my data collection, we conducted this pre-registration. And the nice thing about this is that really you can find all of that under the main project parent. So you've got the big project, you've got all the information about what's happening in this project, you have the current files of everything that's in this project, and then you also have the linked project, which are the registrations. The way that you see these registrations, not from here, is if you go to this tab called registrations, and you can see that there's a registration that was created by us. This is an open-ended registration, and you can view it, and you can update this, and you can do all sorts of things that we'll talk about a little bit later. But this is just to say that all this appears within the main project in a research project that you have. Finally, at the end, because this is a very active project, then just published this year, so you can see that every little step, including updating the wiki about this being published, about creating a custom citation, everything is very well documented here. So it's very, very difficult to, so the only way to get rid of this recent activity cannot be edited. The only way is to just delete this project. So it ensures full transparency that you can see if some file, for example, I don't know, you have access together with a student or collaborator and you're not sure where did one file go and where can I find it, then you can go here and you can see all the updates about all the activity that's been done in a project. When you have massive collaborations and many people are doing different things, this is a good way to keep track of what everybody is doing. And also if some peer reviewer wants to check, wait, when was this file uploaded? When was this changed? Then everything just appears here in the log of the recent activity. Yeah. Here you have the persistent DOI, and this is the thing that we share from the abstract in the actual publication. All right, so we cover this functionality about registrations, contributions, and anonymized view-only links. So I'll talk a little bit about these pre-registrations and what is the difference between a pre-registration and a register report. So basically what these pre-registrations do is that they create a frozen point in time, a snapshot. They create an entire copy of everything that's in the project. So if you uploaded files, or if you did something in the wiki, or if you put some kind of feature in the project, then this will create a copy of that, move it into an archive, and then it will forever be under this project. Why would you need that? So I'm going to talk very briefly about the need for that. I use many case studies, but this is the case study that perhaps people can feel connected to. In 2015, there was this case study about a lot of media attention gone to this research study. It's a real research study about the connection between eating chocolates and losing weight. And what was interesting about this finding is that they found an association between eating more chocolate is associated with losing weight. And you can see a lot of websites really like this, and it became very viral. Millions of people tweeted about this. It was in the morning shows, in all the American TV channels. Big news for us that we don't need to go to the gym, or we don't need to think about what we're eating. We just need to eat more chocolate in order to lose weight. What's nice about this is that John Buchanan is the person who did this study. He came afterwards and wrote this blog post saying, "I fooled millions into thinking chocolate helps weight loss. Here's how." He did this deliberately, but I think when I was doing my PhD 2009 to 2014, it seemed like some of these things were almost like a common practice. So here's this little dirty secret, science secret, that he says: if you measure a large number of things about a small number of people, you're almost guaranteed to get the statistically significant result. So what did he do in this study? How did he get this association? So it's a real association between eating chocolate and losing weight. But he did 18 different measurements: weight, cholesterol, sodium, blood protein level, sleep quality, well-being, and so forth. So he had many dependent variables. And then he wanted to see which one would show up as significant. And if you have so many dependent measures, just by the randomness of the universe, one of them is likely to have a p-value lower than 0.05. Still, he didn't get this. So he had 15 people. This already ensures that there's a very high error, so big fluctuations for each one of these DVs. But just to push this even further, he had 15 people, but one of them, he decided, okay, looking at the results, this one seemed like maybe he was sick that day. So if I just take this one out, then p-value is going to be lower than 0.05. And then I can get this association between eating chocolates and weight loss. So of course, when he published the study, all these headlines did not say, okay, we measured 18 different things and we measured this only on 15 people. And out of the 15 people, one of the people, participants, was dropped. The only thing that he reported at the end is, I found this association, p-value lower than 0.05, between eating chocolate and losing weight. And he says this is a study recipe, study design recipe for a false positive. So it's not like this is not real data. This is real data. This is not, he didn't fake that data, but he definitely capitalized on the randomness of the universe and the flexibility in decision making, saying, okay, I'm going to choose afterwards which one is my DV. I'm going to choose how I'm going to exclude participant. I'm going to choose what is my stopping for collecting data, and so forth. So in order to combat this, when we were seeing these things at the beginning of the 2010s, as I was doing my PhD, thinking, okay, is there a way to combat this? Some people might be gaming the system and doing this deliberately. We're calling this now questionable research practices. But it could be that we're also convincing ourselves subconsciously, unconsciously, that this is the right thing to do, because we really believe in eating more chocolates and we really think that this is good for you and you can lose your weight. We just need to, find the right evidence for that. So we do more and more and more analysis, or we add another participant and then we look, and we add another participant and then we look. So we just follow the research practices in order to try and find this elusive p-value lower than 0.05. Is there a way to combat this? So the pre-registration that I showed you before is meant exactly for this kind of purpose. So you need to have a plan in advance before you conduct the research, the data collection and the research analysis on that data collection. You need to choose in advance, what is the criteria for success? Is it that it's going to be weight loss? Is it that all 18 different measures need to be significant? What is the kind of evidence that you're looking for? Are 15 people enough, or do you need more? If you peak and you look in the data collection, okay, I collected one participant, then I picked, how do you compensate for that? So now we know that optional stopping, you need to compensate, and p-value needs to, one of the methods is that p-value needs to be divided by 2 every time that you peak. If you exclude participants, how do you decide which participants can be excluded, can be dropped? Is it based on post hoc after you looked at the results, or do you define this in advance? So these are very, very important in order for us to ensure that we're not fooling ourselves. And this is very important for us as peer reviewers when we see this kind of piece of evidence before it becomes viral and appears on all the media. How do we know that this is solid evidence? What kind of parameters do we look at? So when we have a pre-registration, when we saw the actual plan, so for example, if at the beginning this person said, I'm going to collect all these 18, but I don't care about these 17, I only care about the weight loss. And then the way that I'm going to collect the data is that I'm going to approach, a sample based on a power analysis of, let's say, 2,000 people. And then the only exclusions that I will allow are based on these criteria. So you have very, very strict protocols and very strict criteria on how to follow this kind of thing. If I had a pre-registration, that would increase my trust in the results and increase the chance that these results are solid and these results are replicable. So this is why we create pre-registrations. So the Open Science Framework really allows you to do this in all sorts of different ways. I use I am a very extreme user of pre-registration. I do this the harshest possible. So you saw simulated data sets, simulated participants, simulated code in order to show reviewers before data collection exactly what is the statistical test and how I'm going to do this. I'll also show you what the pre-registration looks like in our project. So if we go back over here to the thesis student and we go back to this registration, you'll see that if we go to the registration, click on this, we go inside. So this is already the frozen version, and we go into the files, and we go into the archive, we go into the stage 1, and we go into the final manuscript that was accepted following the review. Then you can see we can open the final preprint. It has all the metadata and all the things, but I just want to show you. So first of all, everything that we do is very transparent. So all of things that you see over here is a snapshot frozen in time before we even conducted the data collection. So if you go over here, you'll see a lot of disclosures, and we also believe in giving credits to different people. So we have contributorship using the credit model about who did what in what stage. Then we have an abstract, and what you'll see here is very unique. You'll see in the abstract, important, method and results were written using randomized data set produced by Qualtrics to simulate. So these are simulations of what this might look like at the end. So we actually don't know what we're going to find. So in the pre-registration, we just write it. Did we find support or weak to no support? We don't really know. So we just put placeholders. We actually write the entire manuscript, including the introduction. So the change from before the data collection and after the data collection is not for the introduction. The hypotheses are going to be the same. Everything that we analyzed is going to be the same. The methods are going to be the same. You can see over here in the methods that in the pre-registration, method and results were written using randomized dataset. And here we just write out all of the things. How are we going to recruit participants? We're going to recruit participants based on this power analysis, leading to, what was it, somewhere here, 775 participants. And then we just simulated a data set just to show reviewers what these participants might look like. How are we going to recruit this? What kind of data quality assurances do we have? What kind of pay we're going to give them? We even give a Qualtrics survey preview to allow peer reviewers to see what we're planning to do. And then we set out everything. So the entire manuscript, including the method section, is already written as a pre-registration. And finally, when we get to the results, you can see that we have some results, but these results are based on simulated data. So all of this is just random noise. And then finally, when we conduct the data collection, the only thing that we need to do is take the new data set, plug it into the code that we already wrote for the simulated data, and then all the numbers come out, and then we can update them over here. So all this is just a stage 1 pre-registration in order to share this with reviewers, in order to show them what's going to happen. So this is a very, very strict kind of pre-registration. So I tell my students, I want me to understand what you're doing. I want the peer reviewers, the editor to understand what you're doing. Therefore, a pre-registration just looks like a manuscript, has simulated that, even with the results section. The only thing that it doesn't really have is finally the discussion, because we don't have any data. So there's like really nothing to discuss. So we just have a lot of placeholders about what is it that we're going to discuss, limitations and future directions. And finally, when we conduct the data collection, the only thing that we need to do is we need to update the numbers in the results. We need to write our results section, and we're done. This is the only difference between a pre-registration in my case and a full project with the data collected afterwards. Most people do this a little bit differently, and I just want to show you some of the functionality that you can do. You have many kinds of pre-registrations. So let me just go back to the project that we had. Yeah, this example over here. So this is just like a testing project that I created, but this is one of the pre-registrations that I created for that. But let me just go and show you how I created this pre-registration. So in order to create a pre-registration, so I want to, for myself and to show others, I want to create a frozen copy of my project. So what I can do here is I can go to the registrations, and you can see there's already one that's in there. And I can add a registration over here on the right. Now, the question is, do you have content for registration? Let's say that we have, and which project we want to do the testing, and what kind of registration would you like to create? And now here you have a choice. So actually, there's many kinds of pre-registrations. Pre-registration that I usually do is this open-ended registration because it looks like a manuscript. I just upload an entire manuscript that has all of the introduction, the methods, and simulated data result section. So for me, for the open-ended registration, I just upload this manuscript and I ask it, please freeze that manuscript. But let's say that you want something simpler. You can use one of these, for example, generalized system. So this is for meta-analysis, or another option for you is to do an OSF pre-registration, which is a little bit more detailed than that. And here you'll see that there are a lot more tabs. For example, a study information. All of these are optional, so you can say what kind of fields you want to do. But if you move to study information, what are your hypotheses? And you can see, like, for example, an example here. Design plan, which is it? Is it an experiment or observational? Do you do any blinding? Are there any additional blinding to the study? Study design, upload files if you need any files, how are you going to randomize? So if you don't have the manuscript structure and you don't know how to do a pre-registration, then the typical OSF pre-registration already tells you what kind of things you want to be thinking about. So you can just go step by step, follow this whole thing, and then just choose the things that are relevant to you, or describe how it is for your project. You can see that some of these things have an optional tag to them. So that means that you don't have to, but some things are mandatory for a pre-registration template. So if you're just doing a typical pre-registration for data collection, let's say here it's like an experiment or a correlational study, you can go through this whole thing here and then finally review and then ask it to pre-register. If you go back, we'll go back one. Here. Yeah. You'll see that there's other things that you can do. So if you're doing a replication, for example, if you're doing a registry report, or if you're doing qualitative, so for example, if you don't have any quantitative data and you're doing something differently, for each one of those domains, a team came together in order to try and give you the best fields that would help you to do a good, high quality, rigorous, transparent pre-registration for you. Even if you're doing a simulation study, some people do, or theory-based predictions, you can do this over here. I'm part of this group who did the generalized systematic review. So if you're doing a meta-analysis, so this includes slightly different fields. So you can see landing page, a search strategy, screening, extractions, and so forth. And at the end, when you're done with this, it will appear under your, sorry, if we just go back. Yeah, it will appear over here, and then you'll need to say whether you want to actually launch this pre-registration. And the way that this would look like is this. So you go to registrations, you add a new registration, and then you will receive this email. So you can see the email here. Hello, Gilad Feldman, you've requested final approval to submit registration. So for example, if your student decided to register this and you're the administrator, it will ask you, do you want to approve this or not? One of the questions you can see, for example, here it says embargoed registrations. One of the questions that people ask is that, do I have to share this pre-registration with the world immediately or not? And the answer is you don't have to share this right now. But eventually it will always be shared, and you can have it for an embargo of up to 4 years. So if you do a pre-registration, but you don't want other people to know that you've done a pre-registration because you want 4 years in order for you to publish this, then you can set an embargo where this will become publicly available 4 years into the future. But all the pre-registrations eventually are shared with the world in order for other people to know that you've done this, and that this is public, and that this is associated with this project. So if I'm the admin and my student asks for an embargoed registration, then I just go here, click here, and then it becomes official, and it shows up over here in the testing accepted. Right? And then I can just go into it, I can view it, I can share this with others. So you can see there's like associated project and a registration. So I just share this link with the peer reviewers. Okay, this kind of citation. In addition, there's all kinds of things that you can do. So for example, here you can see that in a pre-registration, you have, this is a public pre-registration, so I did not do an embargo. You can withdraw a registration. So let's say that you've done one in error and you're sure that you'll never need this pre-registration ever again, then you can withdraw the registration. But if you do this, then it removes its content from the OSF, and you'll never be able to, again, share this with others. So this is irreversible. So you just need to be very, very careful with this. Some people say, what happened if I pre-registered, but now I have a different agenda and different kind of criteria. Then you go on updates here, and you can update this. So you can already see that I've done one update. I think it was over here, the hypothesis, updating process. Yeah. So you can look at the original, and you can look at the latest, and you can see the differences between them. And every kind of change that you make, so for example, if you update a pre-registration, it will give you another notice and an approval. So if the student updates a pre-registration, then it will reach out to you as the admin to say, do you approve this? This is what happened. So you have full control. If you have collaborators, everybody knows whether a registration has been updated or not. If it's embargoed and you want to make this public, let's say that you set the embargo for 4 years, and then you want to say, okay, I want the embargo to end now. You can do this using this end embargo early. And then once again, you need to approve this request. And then you can also withdraw a pre-registration, give a reason, and then another email saying it was just a test. Please approve this. And once you approve the withdrawal, then the pre-registration is erased forever. So this is what pre-registration looks like. You have a pre-registration that is very, very simple. It could be a few words. There's one that follows a template from the Open Science Framework. There's one that follows a template by different teams, so meta-analysis and so forth. And there's one that is very strict, like mine, that does a full manuscript. Now, if you're thinking a full manuscript seems like a lot, how do your undergraduate and master's thesis students do this and do this so well? Is that we created a lot of templates for you. So if you want to use our template, you can go on my website and you'll see that there are resources here. Many collaborative resources. We've created a lot of different guides. So for example, if you don't know how to do a replication, or you don't know how to do an extension, or you don't understand effect sizes, you don't know how to do a power analysis, we've created a lot of guides for you. So you can go here and you can see our effect size and confidence intervals guide. For example, I'll open this for you so you can see this. A power analysis guide, I'll open this so you can see this. But in addition, you can also see that we have a registered report manuscript template. So if you want to write your own manuscript for pre-registration, you can just go on this link and it will show you everything. So my students with these templates are able to result in very, very detailed, comprehensive pre-registration plans before data collection. And you can see that it has everything, all of the things that you just saw in the projects are available here. The only thing that they need to do is go step by step, page by page, in order to update the different fields that are in there. So for example, the abstract, what does the abstract look like? So this, the importance notice at the beginning, and then what it needs to be written in the abstract, everything is in this template. So you can just go on my website, you can go to the resources and examples, and you can see that there's a template for a registered report, how to do pre-registrations. There's also templates for how to do a registered report for a meta-analysis, for other experimental or correlational. So most likely is if you've done quantitative work and you need a template, we have something for you that might be very, very helpful. So the only thing that you need to do here is to go to File, make a copy, make this your own, and then work on that. Share this with your students or your collaborators, and then it just gets you started a lot easier and gives you all the comprehensive things that you would expect from a pre-registration, like power analysis, all the participants, the procedures, the predictors, manipulation. So you can see this is a lot more detailed from the already very elaborate and detailed OSF pre-registration. So a lot of guides, a lot of templates, a lot of things for you to use from our resources. Okay, how are we with the time? Okay. All right, so this stage is just, I think we went over most of the things. I just want to show you that this is possible and very easy to do, even with undergraduate students. So this is an example with Timothy. He also gave HKU brown bag, and he concluded after he was able to turn his thesis and another course project with me into publications using very high transparency, open science registry report, is that he wrote a Psychology Today column summarizing his experience of working with Open Science Framework and working with the peer community in Register Report, and summarizing this as the best learning experience for researchers. So I'm really hoping he'll stay in academia and move on to do wonderful things also in industry. But now he has this very high level of executing, of sharing, of being as transparent as possible using the Open Science Framework with all of that. So you can see peer community and registry report at the beginning in stage 1. After we submitted this OSF link of our manuscript, we submitted this to publication, it received a recommendation, then we conducted the data collection, and then it analyzed, we changed everything in the results section to the real data, and then we submitted to stage 2, and this was recommended and finally accepted for publication. So once again, you can see that at the end over here, the materials, the data in the code always point to the Open Science Framework. So we have full transparency about the stage 1, the stage 2, and in each one of them, all the data in the code, all the materials, and all the questionnaires. So just like this very, very strong integration between Open Science Framework and what it gives you, and everything else that we do in our research process. The registrations, the sharing of the data in the code, the anonymized peer review, creating the links, having a DOI, everything is just very easy with a few simple clicks within the Open Science Framework. Okay. So I think we covered a lot of ground and quite fast. I hope this was clear enough. But I think just using the last few minutes, if you have any questions, if you want to raise anything, then I'm happy to answer. I'll just say, because I'll talk, if nobody's asking anything, then I'll talk about one last thing. But before that, I just want to say, this was very, very fast and it covered a lot of ground. And perhaps you can, of course, download all the slides here. This is the link on the bottom right. But you probably have questions. And if you have questions, I'm very, very happy to support you. Behind me or together with me is a very large team of other people who have used this, like Timothy that I just showed you, and who would be very, very happy to help you in your own journey. So I just want to say everything that I just showed you, the resources, the materials, the talks, the OSF, everything is on this link. You can scan the QR code. Please don't hesitate to contact me. I promise to answer, even if I'm busy. I might connect you with somebody else who will give you like better answers or will be more responsive. We also have a mailing list, so all the things that we do, all the activities, all these register reports, all these talks by students, everything that we do in open science practices, this notice comes out every 2-3 months. And then there's this YouTube channel that has all the things that I publicly do, courses or talks or workshop or anything else. So please don't hesitate to get in touch. Okay. To start off, when you share stuff on the OSF, you share stuff for yourself or for the team. So there's no like oversight regarding what is it that you share. Everything regarding the research can be shared and made available or can be kept private. So you can just use this as storage for your teaching materials, storage for your research materials, whatever it is. It could be complete garbage. It could be uploaded to the Open Science Framework and kept for you or for your team. If you want, you can also make this public. Based on this platform, you can add additional processes or services for other people, like the community, to come in and evaluate this. So, for example, we use a community called Peer Community. I can actually show you who they are. So, Peer Community. Peer community in. They have a lot of peer communities. So we use peer community in register reports, but you can see that there's actually quite a few of them. If we do peer community, so there's one in psychology. Let me see what to publish. So this community goes on the open science framework based on a DOI that you provide. So for example, you've uploaded a manuscript and this is now can create it to become a preprint. And you can tell others, I want you to evaluate me and I want you to see how good things are. So based on that, they will start a peer review that is very similar to a journal peer review. So they'll go to the DOI and they'll check your files and they'll see, is this high quality or not high quality? And finally, after this happens, so I'll just show you peer community and registry reports. So this is peer community and registry reports. You'll see that it has recommendations. So for each one of these projects has a stage 1 or stage 2 if it's completed. It gives a recommendation. The way that this recommendation, what it looks like, is that based on your OSF, so this is the preprint on your OSF, it has reviews by identified people, experts in the field, and a recommender, and you can read all the recommendation. So what is the recommendation? The URL on the OSF, where this is taking place, and then what were their reviews and how people answered the reviews, so you can actually read the author's reply to the reviews, right? So all the back and forth between the community and the people based on the files on the OSF can be done on peer community and be made public. Peer community is not the only platform. So for example, the Center of Open Science has a different, I think it's called Life Cycles. Center Open Science. I think it's called Life Cycles. Yeah, Life Cycle Journal. So they do something very, very similar. They have different people checking different things. So some people are checking the data. Some people are checking the registrations. Some people are, so each element that you have on the Open Science Framework, there is somebody in the life cycle that will go and check it. It's optional. You don't have to do this. You can use the OSF as you want, but if you want to increase the credibility, to increase showing to others that what you're doing is solid, then you can request peer community or life cycles in order to come in and check your work to show that you're solid. So if you go on my CV, you will see that what publications have gone through peer community and registry reports, and this gives it an additional aroma, not just a flavor of credibility. In addition, let's say if it's not published yet, or in addition to a publication, you can say that the community has found this to be rigorous. But for example, in the life cycle journal, you have like a code check. So now you have experts that are checking code in order to see that this is really reproducible. If you're doing anything regarding meta science, so they have an open review, transparency, paper wizards. So a lot of these different people are coming together in the open science community in order to ensure that that the stuff on OSF is solid. And then, of course, you've got citations because everything has a DOI. Sometimes me just sharing a talk or research materials, or let's say my course. Sometimes I get citations to my course. I get citations to a talk that have nothing to do with my research. It's not a publication, but the more citations that there are, you can see that the community is paying attention to this and that they care about this. For example, peer community, if we have like a moment, I can just show just how amazing this is, because we really use this for many things. Let me see if I have. Yeah. So Timothy again, who did this in peer community, I think it's really remarkable that a 6 to 8 months thesis by an undergraduate student can be published in a real journal using this peer community and registry report. If you want to know how this magic happens, you can go and listen to actually Timothy promoting this. But what I want to say about how this is possible is because we've used a platform called Peer Community and Registry Report. And this is what the community looks like. It has a bunch of things that are available. So it's not only that it does peer review on preprints, but it also offers a lot of different other benefits. So for example, it guarantees if you do, it has a scheduled track, it guarantees peer review within 2 weeks. So that's the way that we're able to conduct this in 8 months. In addition, you do the peer review once with the community, but once the community endorses this, you choose which one of the journals you want to publish with, which is completely amazing. So you've got Collaborative Psychology, International Review of Social Psychology. Once this is endorsed by the community, they will publish this with no additional peer review. So instead of, submitting to this journal, okay, decline, then I go to another journal, decline, you go through this once with the community based on the highest standards of open science, and then you as the author have the complete control and power to decide which journal you want to publish with. So if you go to to peer community, for example, here, peer community in registry reports, you can see which journals are affiliated with this. So the important thing to keep in mind, so some people say, why would they even share anything? I don't want other people to copy what it is that I do. I don't want them to beat me to publication and, just take what it is that I've done and publish with it. Once you've uploaded this to the OSF, especially if you've done like a registration, everything, you have a very easy way of doing a DOI, and then everything gets recorded. So you have a very detailed log of when did you upload this and who accessed this and all of that. So let's say somebody comes in on a certain point in time and say, this was my idea, then you can very easily show that this, in an earlier moment in time, you've uploaded this and you've created a DOI and all of that. Now, if somebody still abuses this and beats you to publication based on your own data or something that you've shared, you can take action in order to try and prevent that. But if you have not done that and somebody has stolen from you, then it's very difficult to prove this. But because everything is transparent on the Open Science Framework, that this allows you, at least when there is a conflict, or let's say there are two teams and they're saying who came with this idea first, at least the OSF, because everything is transparent and logged, for you to show an editor or show a journal, I was there first, this was my idea, in a moment of time, I was the one who published this kind of idea. If somebody still does this kind of thing and it's not, I don't know, a journal needs to decide or the community needs to decide if it's something more regarding like IP, or let's say, for example, an AI company decides to just take everything and load this into their AI, there's not much that you can do other than to use the force of the law and to sue them. But the OSF does not do anything to prevent that, aside from if it's private, then only you see that. And if it's public, then it has a DOI and everything is documented so that you know exactly, it's publicly recorded with evidence when that took place and that you were there, so that if you wanted to take legal action, that you can use the OSF records in order to show, here, this is based on mine, and I uploaded this and I set the license to be that it cannot be used for commercial sense. So this is the only protection that you can have. Whenever you conduct open science, if you decide to share everything publicly, then you need to take into account all the extreme cases of where somebody is going to use this for purposes that were not intended. But if you upload things publicly, you set a DOI and you set the right license. Until now, I have been sharing things for 10 years, at least in psychology. I don't know how it is in other fields. I have not seen any kind of situation where somebody took my thing and pretended this to be theirs. If anything, what usually happens when I share is that people reach out to me and says, this is amazing because we've also worked on something like this. Do you want to work on this together? And then we combine forces and we come out with a publication together or with a tool together or a resource together. So for me, this has been an amazing tool for collaborations and finding other people who are interested in the things that I do. I hope that answers the question.